Hi there, this is Krishna Menon, industrial expert in the field of electrical engineering from 9th. Today we are going to see about transistor as a switch and its industrial applications. Let's get started. The contents which we are going to discuss today, how the transistor as a switch, and when the transistor is in off state we used to refer cutoff region we will discuss, and when transistor it is in on state we used to refer saturation region, that also we will discuss with an example. Finally we will see what and all applications when the transistor as a switch. Before going to discuss about the switching, let me introduce about the basic transistor. Transistor is nothing but either N-type or P-type semiconductor sandwiched or connect between two P-type or N-type semiconductor respectively. Then both N and P-type will form a junction. We used to refer to PN junction formed. Such a two-junction device is called transistor. Thus, transistor is a two-junction, three-layered, and three-terminal semiconductor device. The transistor made by either silicon or germanium material. So, mainly there are two type in the transistor. One is PNP transistor, and one more is NPN transistor. Here is the graph how the transistor it is getting the switching. So, as per the graph, we need to apply the voltage and current to the transistor. So here that output with respect to current, we are plotting the curve. The input voltage we can say VBE, and the input current we can say IB, base current. And VCE and ICE we can refer output voltages. So the plot we are plotting between output voltage and output current in terms of input current is constant. Initially, the base current it is in zero. There will be a minimum voltage where we can say VCE. So that the minimum is a saturation current we used to refer. So that region from zero to that minimum current we used to refer cutoff region. During the time the transistor fully off. When we are rapidly increasing the IB value from 1, 2, 3, 4 up to on, the current and the IC current at that output side it's gradually increasing. So that curve we can see over here, that saturation region we used to refer. That time transistor it is fully on. Let me explain each and every part in the region. First we will discuss about cutoff region. Cutoff region, when there is a voltage, the transistor it is in closed state. In the sense there is a input and the transistor switch is closed. But when there were no input voltage, let's say V in is equal to 0. So there is no input and there is no IB current, input equal to 0. As we are already discussed in the curve, here you can see when there is no input, IB is equal to 0, there will be a minimum voltage. We used to refer that is cutoff region. That time transistor will be there in a cutoff region and fully off mode. And second stage, it's a saturation region. As we discussed earlier, when the IB current rapidly or slowly increasing to the final value, that time there will be a region which you use to refer saturation region. That time transistor will be there in a fully on mode. So by making this transistor by acting in a cutoff and saturation region, we can use as a switch. Here is an example. I'm going to explain that using switch and one logic. Logic in the sense one is 0 that is low, one is high 5 volts. So here I'm using one switch. When the switch is in open condition, logically we can say low. So here I'm applying one 12 volts and indication I'm using a LED and one transistor that is NPN transistor. When the switch it is in open, there were no base current in the transistor. So LED will be off. When the switch is closed, there will be a voltage across R1 and this digital logic also will sense the 5 volts. So there will be a IB current. The transistor is going to the saturation region. So once it's a saturation region, that LED will be on. So here you can see what and all applications industrially we are using as a switching. First thing is a controlling the lamp circuits, relays and motors. When we are using the bipolar junction transistor as a switch, there must be a fully off and fully on condition. So fully on condition we used to say saturation, and fully off we used to refer cutoff state. So particularly transistor will be applications are used for saturation or cutoff region. And when the transistor it is in a middle, in the sense there were no saturation, there were no cutoff, there is a middle region. In that, where there will be a small base current controls a much larger collector load current. So we can use as a load driving circuits. When using the transistor to switch on the inductive loads such as relay circuits, solenoids, we need to use flywheel diode for the protection. When larger current voltages need to be controlled, Darlington transistors can be used. In the sense, Darlington it is having the more gain. Thank you.